Hello, ladies and gentlemen. This is Mr. Miller here with your Algebra 6.5 notes, solving exponential equations here. We have actually three sections on this notes that we'll be able to do here. The first one is solving exponential equations with the same base. Second, we'll solve exponential equations with unlike bases. And then third, solve exponential equations with graphing. So when we can't find like a same base or get to the same base, when we have our unlike bases there. So we'll solve those last ones by graphing. First property here is the property of equality for exponential equations. So if two powers with the same positive base b, where b cannot equal 1, are equal if and only if their exponents are equal. So what that means is, as we're looking at this example here, our first examples, if we have bases that are exactly the same and they're positive bases and they are not 1 obviously, so we have a base of 3 here and a base of 3, to set these equations equal to each other we kind of ignore the bases because they're already 3's. So to make this equation equal, all we have to do is let the powers be equal. So here we have x plus 1 has to equal 5. So we're just taking the powers and then solving real quick. So we subtract 1 from both sides and x equals 4. As always, we can check our work by throwing it back in. So again, just a quick little mental, if we throw 4 back in there, that would be 4 plus 1 is 5, and again you would get 3 to the 5th does equal 3 to the 5th for our answer there. Second one here. So remember, anytime you have just a number by itself, remember that is, we have positive signs there in front of that we don't have to put in front of. Also, we have the power of 1 that we don't put into the equation either. But for solving purposes, we have to. Again, our bases are exactly the same, 6 and 6. So to solve this, it is simply 1 is going to equal 2x minus 3. And then we have a two-step equation here to solve for. So we add 3 to both sides. So we get 4 equals 2x, and divide by 2, and x comes out to equal 4 divided by 2 is 2. And again, if you get lost, don't forget, throw it back in there. So our answer is 2. So our mental math here, 2 times 2 minus 3, and that's going to be 4 minus 3, which is an answer of 1, which that's what I wanted. So this comes out to 6 to the 1st equals 6 to the 1st, making both sides of our equation the same. So I'll let you go ahead and do this last one here. Again, both of our bases are the same. Just a algebra problem there. But recognizing that when your bases are the same, we can set those exponents equal to each other and solve. For the second set here, so these ones will take a little bit longer here because these are solving exponential equations with unlike bases. So if we have unlike bases, we're kind of in the in-between area here between knowing what the base is and just graphing it out to get the answer, which we'll get to graphing here after these ones. These ones, you can figure out what the base is going to look like. These are a little easier here. So we will make the bases exactly the same. So sometimes the hints are in the question here. So this is a base of 5. So that means, that's my hint, I can actually change this to a base of 5. So 5 to some power is what I'm saying is going to be 125 there. So it might take your little calculator work here to figure out what that is if you're not good with your powers yet. But this is 5 to the 3rd. So I'm going to write that up here. 125 is 5 to the 3rd. So we're going to make that substitution. And again, my hint came from, I had a base of 5 there. So rewriting my equation, 5x is going to equal 125 is 5 to the third, so we're going to substitute that in, 5 to the third, and then we're back to where we were. So what does x have to be in this case? X has to be 3. Moving on to our second one here. So again, we got two different bases. Always have to go to the smaller one, and that is your hint. So there's my smaller one there for that one. So we will change the first one to a base of 2 there. Just real quick. So I'm changing that 4. So here, just a little squiggly here. We're going to change that to what is 4? 4 is the same as 2 to the second power. Now there is an x there, so that connects to it. So we don't want to get rid of that. So we're just changing it 2 to the second power, and then we had that x there. So again, it's multiplication between those two. So it'll just be that 2x. So we get here, rewriting 2 to the 2x. That is going to equal, and the other one's already in the base of 2. And then we have x minus 3. Our bases are now the same. So now we can set our exponents equal to each other and see how we did. So 2x equals x minus 3. Subtract x from both sides, and x is going to come out to equal a minus 3. So I think that's my answer, but again, we want to make sure that we check this. So we're going to go through the process of checking this as well. So throwing it in, we have here a 4, and I'm actually going to break it up here. So we have 4 to the minus 3 power, which again, what does that mean? Anytime we have a negative exponent, we don't leave it that way. That's going to change. Again, it moves in the fraction, so we flip it. So it's 1 over our 4 to the third power, which that will be an answer of 1 over 64. And again, if you're not good with your cubes yet, just go ahead and put that in your calculator. But 4 times 4 times 4 does get us 64. Checking my other answer to make sure I get the same thing on both sides. So that is 2. I'm plugging in that minus 3 more. So that is going to come out to 2 to the minus 6th, which again, that works out to be 1 over 2 to the 6th. And again, I don't anticipate you to know that. So we go 2 to the 6th power, and guess what? We get an answer of 64. So that does come out to 1 over 64 as well. So our answer is 100% correct. Next one is a little more challenging. So we've kind of ran out of hints here with the first two. We could just go to the smallest number that we have. Here in this one, squiggle, 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 give myself a room. We have a 9 and a 27. So 9, for as far as powers goes, is obviously 9 to the first or 3 to the second. That's the only whole numbers that get us there. So we do have a relationship with the 3. So this one you had to kind of work with your multiples a little bit. 3 goes into 9 and 3 goes into 27. So we're looking for that lowest common multiple there if it is not given to us like in the last question there. So there is a little bit of work that you had to do with that. So we're going to change this 9. So again, 9 is the same as 3 to the second. A little side work here. So we need to figure out what 27 is. And it has to be the same base there. So that is actually going to be 3 to the third. So we have our two bases. We just need to make sure we're putting them in. And again, it's multiplication here because we are changing the powers that are to a power here. So when we change this, throw that 3 in, it is going to be 3 to the third, and it is multiplied by that x plus 2. All that equals my 20, oops, not 3 to the third. 3 to the third is 27. 3 to the second, let's try that. Again, when I checked my work, it would have been not so good. So make sure you grab the right one. So 9 is 3 to the second, and then the parentheses, x plus 2. And then our 27 here is going to be 3 to the third, and then times that x. Our bases are now the same, so our equation becomes 2 times x plus 2 in parentheses. All that equals 3x. We're going to go ahead and distribute. So just kind of working my way here so I have a little more room to check it. So we get 2x plus 4. All that equals 3x. Subtract 2x from both sides, and we get 4 equals x. So again, I think that's my answer, but like a lot of things we do in this class, we can check it. So if this is truly my answer, when I plug these back in, I will get the same equation on both sides. So what I mean by that is when I plug it back in, 9, throw the 4 back in there, that's 4 plus 2. So again, that comes out to 9 to the 6th. And then I'll calculate that on my calculator here in just a second. And then our second one that we're going to check is plugging it into 27 to the x, which x is 4. Those should come out to exactly the same answer there. So bringing up my calculator here, oops, covered up my work, I can't see my 9. So we got 9 to the 6th. Oh, can't see that. There we go. SOAR coming in. Let's get it out of there for a moment. Well, it was working earlier. There seems to be too much glare now. Well, I'll just write it down. So 9 to the 6th actually comes out to 5, 3, 1, 4, 4, 1. So that's what comes out on my calculator. And then, again, you can hear me typing it into my calculator, 27 to the 4th. And guess what I get? I get the same exact answer, 5, 3, 1, 4, 4, 1. So both sides of my equations come out to equal the same when my x is 4 there. Flipping over to the back side here, we're going to do 2 more that here that a little more challenging. So when we're looking at trying to get these the same, we want a whole number, all right, to get them the same. So here we're actually going to do a little manipulating on this fraction. So I'm going to look at inside this fraction, and I want to change it to a whole number that we're going to manipulate here. So what I mean by that is, if I have 1 over 2, I can change that 1 over 2, ladies and gentlemen, to 2 to the minus 1. So again, we're kind of reversing what we did back when we were playing with our negative powers. So anytime you have a number that is in the bottom of a fraction, we can always change it back to a negative exponent to help us solve the equation that we have here. So when I change that back, I notice I have a base of 2. Well, that's good because 4, I can also change that into a base of 2 as well, because 4 is the same as 2 to the 2nd power. And then I would have both my bases be exactly the same. So reverse engineering this using our negative exponents, which we'll do that here in a moment in this one as well. So my bases are 2 to the minus, and again I had that x on the outside, so this is actually going to change to 2 to the minus I'll go ahead and put the 1, and then again it's times the x that's there. So actually I could have just had it as a minus x. All that equals, and then 4 is 2 to the second. Bases are the same, so I'm going to clean this up. So I'd have just minus x has to equal 2. And then again we need an x by itself, so we divide by minus 1, divide by minus 1, and x comes out to equal minus 2. Again, checking our answer. So I already have 4, so when I plug this in, so I have 1/2, all of that to the minus 2. Use my calculator to check that. So open up my parentheses, or I could put in 0.5, but 1 divided by 2, close my parentheses. And all of that is to the power of minus 2. Again, let's see if we can start to see any of that on my calculator. There we go. And notice that 1/2 to the minus second comes out to 4. So I do get my 4 answer. So I know that is 100% correct. Last one here, and then we'll actually go to a part B video, because the rest of this we'll be using Desmos for graphing them out. So I'll be on my different recording here. So we have a 4 and a 64. First things first, I need to get the 64 out of the bottom here. So we're going to reverse engineer this. So 1 over 64 is the same as saying 64 to the minus 1. Now, here's our hint again. 4 actually will be a exponent, a power. We can take 4 to the exponent to get 64. If you didn't see that, 2 actually works as well. So we have actually 2 choices here to get to 64. And I'll write them up here. So it is either 4 to the 3rd power is 64, or it is 2 to the 6th power is actually 64 as well. So we have a base of 4 or a base of 2 that we can use with this one. So we get actually a couple different ways that we can go through this one. I used the base of 4 just so I wouldn't have to change this one. So it actually works out kind of nice on this one. So on some of these questions, ladies and gentlemen, you will have to play around with them. So I'm going to leave that as that. So I just need to manipulate my other one. So my other one, 1 over 64, is the same as 4 to the 3rd. So again, I have a minus 1 there, so I need to do a little work here. So it is 64 to the minus 1, which that is going to change to 4 to the 3rd times that minus 1. Because again, we had the minus 1 there, so I'm changing it. Can't forget about that minus 1 that gets multiplied to the power there. So then we have, and I'll just rewrite everything here, we have 4 to the x plus 1, all that equals 4 to the minus 3. And again, our bases are exactly the same, and then we're back to just saying our powers equal to each other. So x plus 1 equals minus 3. So I'm going to subtract that. X is going to come out to equal minus 4. And again, check your work. So throw it back in. So if I have 4 and my x is minus 4, I think, plus 1, what does that come out to be? So that's 4 to the minus 3rd. And again, we'll use our calculator here, or you can actually clean it up with fractions if you want. Either or. So again, when that's a negative exponent, remember we flip it to make it positive, so that becomes 1 over 4 to the 3rd. And again, 1 over 4 to the 3rd is 1 over 64. So we had that right up here, our math work. So I won't use my calculator, just use my previous math work. And again, we're 100% correct. Alrighty, so I'm going to switch over my recording so we can do it on the computer with Desmos here for the graphing. So we got a couple equations here that we'll do with graphing. So part B, look for that. Thanks, ladies and gentlemen.